Each of 20 balls is tossed independently and at random into one of 5 bins. Let P be the probability that some bin ends up with 3 balls, another with 5 balls, and other 3 with 4 balls each. Let Q be the probability that every bin ends up with 4 balls. What is P over Q? Okay, so first of all, let's see what we have. We have P is the probability that some bin ends up with 3 balls, another with 5 balls, and the other 3 with 4 balls. So P is equal to, remember what probability is, number of desired outcomes divided by the number of total outcomes. So the numerator here would be number of ways to get our desired distribution, 3, 5, 4, 4, 4 in some way, shape, or form. And the denominator is going to be number of ways to put balls in boxes, right? And similarly, Q is equal to number of ways to get 4, 4, 4, 4, 4 split, number of ways to get 4, 4, 4, 4, 4 over this thing, number of ways to put balls in boxes, number of ways to put balls in boxes, to put balls in boxes. You see that if you have P divided by Q, you're going to get this divided by that. And if you take a look, you actually see that this denominator cancels with this denominator. So P over Q is equal to number of ways to get a 3, 5, 4, 4, 4 split divided by the number of ways to get a 4, 4, 4, 4, 4 split. And how many ways are there to do that? Well, we can count the number of ways to do for the numerator and the number of ways to do it for the denominator, and we can divide them by each other. So let's start out with the denominator because it looks easier. How many ways are there to get every box with 4 balls? And for this solution, what I'm going to do is I'm just going to assume the boxes are all distinct and the balls are all distinct. So I can tell all of the balls apart. For example, all of the balls may have different colors and all of the boxes may have different colors as well. So what I'm going to do is, in order to count the number of ways to get a 4, 4, 4, 4, 4 split, what I'm going to say is, okay, I'm just going to arrange the 20 balls in a big long row. 5, 6, 7, 8, 9, 10, 11, 12. You get the point. 13, 14, 15, 16, 17, 18, 19, 20. I'm going to count the number of ways to order the 20 balls. And what I'm going to do is I'm going to say, okay, I'm going to put dividers here, 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 and here. And everything in this region goes to box 1. Everything in this region goes to box 2, and so on and so forth. So how many ways is there for that to happen? Well, you'd think it would be 20 factorial because all of the balls are distinct. So there are 20 factorial ways to rearrange the 20 balls. But actually, we're overcounting because if we have an order like this, let's call the balls A through T, and the balls are ordered A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T. If that were to happen, we'd have A, B, C, D in the first box, E, F, G, H in the first box, second box, I, J, K, L in the third box, M, N, O, P in the fourth box, and Q, R, S, T in the fifth box. Well, that's exactly the same as something like B, A, D, C, H, E, G, F, I, L, K, J, P, O, M, N, T, Q, S, R. Those two are the exact same because the exact same balls are going to the exact same boxes. And it turns out what we have to do is we have to divide 20 factorial by something. We have to divide it by 4 factorial because there are 4 factorial ways to rearrange those ABCDs for box 1. And for box 2, you also have to divide by 4 factorial. Right? Because E, F, G, H, H, E, G, F, there are 4 factorial ways to rearrange those without changing anything else, and so on and so forth. And since there are 5 boxes, you'd have to divide 20 factorial by 4 factorial 5 times. So that's the denominator, 20 factorial over 4 factorial to the power of 5. Now the numerator, which is how many ways are there to get a 3, 5, 4, 4, 4 split, is a little bit more complicated. And so what I'm going to do in this case is I'm going to do the exact same thing I did last time, which is line the balls up into a row of 20 balls, and then put the first few in the first box, the second few in the second box. And I'm going to actually do it a specific way. I'm going to put dividers like this, so that this one has 3, this one has 5, and the other 3 have 4. But the trick is, this one doesn't have to be box 1. How many ways? So it turns out each of the five bins has could have 3, 5, or 4 balls in them. So how many ways are there to choose the bin that has 3 balls? Well, okay, there are 5 ways, right? There are 5 bins, so you can choose 5 of them to occupy this first slot. There are 5 bins. Now that we've chosen the bin, how many ways are there to choose the bin with 5 balls? Well, since we've already used the first one, we have 4 more left. And the other 3 can have 4 balls in whichever order, so we don't need to choose them. Now, what we do is the same thing as before. We rearrange the 20 balls, 20 factorial ways to do so. Then you have to divide by, well, this first bin, there are 3 balls. So if you had A, B, C, that would be the exact same as if you had B, C, A. So you have to divide by 3 factorial for the first ball, for the first bin, excuse me. Then for the second bin with 5 balls, you have to divide by 5 factorial because there are 5 factorial ways to rearrange those, and you've counted too many by that factor. And then for the other 3 bins, divide by 4 factorial because there are 4 balls in each of the other 3 bins. So 4 factorial cubed. That's your numerator. 20 factorial over 3 factorial, 5 factorial, 4 factorial cubed. So your answer is 20 factorial over 3 factorial, 5 factorial, 4 factorial cubed over 20 factorial divided by 4 factorial to the power 5. You can write this as 20 factorial times 4 factorial to the 5 over 20 factorial, 3 factorial, 5 factorial, 4 factorial cubed. And everything cancels out. Well, most of the things cancel out. This cancels out with that. And oh yeah, one thing we forgot was to multiply the numerator by 20 because there are 5 ways to choose the first one and 4 ways to choose the second one. So you had to multiply the numerator by 20. That's one thing you absolutely cannot forget to do. And I almost forgot it myself, but anyway, you had to multiply the numerator by 20 because there are 5 ways to choose the bin with 3 and 4 ways to choose the bin with 5. Anyway, a bunch of stuff cancels out. So this 4 factorial cancels out with that to be left with 4 factorial squared. Then 3 factorial times 5 factorial is on the denominator, and 4 factorial 20 is on the numerator. You can write this as 4 factorial over 3 factorial times 4 factorial over 5 factorial times 20. This thing over here is 4 factorial divided by 3 factorial just equals 4. 4 factorial divided by 5 factorial equals 1 over 5. So your answer is 4 times 1 over 5 times 20, which is equal to 16. So your answer is E. Thanks for watching, and I will see you next time.